Who spotted a difference between a pattern from a diffraction grating and a pattern from double slits?
What was the diffraction grating? It had like dots.
This double slits was like what we just saw, that made a pattern of kind of blurry, sludgy fringes that was about that wide, whereas the diffraction grating was the one that spread the dots around the classroom. Yeah. Who spotted the difference?
Well, one of them had dots that went around the classroom, and the other one had little slits that went on the whiteboard.
So one was just specific points.
So the angle that we saw the pattern across was greater. So the double slit, the pattern was seen in just a small angle, whereas with the diffraction grating, the pattern was seen spread across around about 180 degrees. So thinking about diffraction, why would that be? Why would it be that one of them is spread real wide and the other one's kind of like a narrow cone? Think about diffraction. What's diffraction?
It's like the waves around a boundary.
Around a boundary or? Through a gap. So that's what we're doing. We're diffracting. Remember when the waves go through the double slit, they're diffracting. When the waves go through the diffraction grating, they're diffracting. One of those seems to be diffracting a whole lot better than the other. Why would that be? What do we need for ideal diffraction? This is like winding back to level 2.
Because it's smaller, it's way closer to the wavelength of the wave.
So slit size is around about equal to the wavelength. So diffraction grating, we've jammed in like 1,000 slits per millimetre. So that means that they're about a micrometre wide, and red light's about 0.65 micrometres wide. And so the slit spacing slit size must be around about on the same scale as the wavelength of light. So we're getting good diffraction. Whereas with the double slit, they're pretty wide spaced, relatively wide spaced. So our slit spacing, our slit size, the width of the slit that the light's diffracting through, is much bigger than the wavelength of the light, and so it doesn't diffract that well. Who spotted another different difference? There was heaps of differences. What was going on?
They were lines and then they were dots.
Right, it's kind of much more concentrated, like light sources.
What do you mean by concentrated?
Brighter, brighter.
The maximum.
Oh, there's two things. Let's do brighter first. So which one had the brighter ones?
The diffraction grating.
Diffraction grating. So brighter. Max, right, and this one had less bright.
Dimmer.
And why might that be? Thinking about shining torches at night and shining lots of torches versus not shining that many torches, why are some of them bright and some of them not bright? Who's ever shone a torch at night? And who's ever shone two different torches at the same thing? What happens? And if you shone 1,000 torches at the same thing? It gets real bright. What's going on?
It's just concentrated.
Constructive influence.
More of the
central maximum.
The light's more spread out. There's more sources in one spot.
Yeah, more sources. Because say we've got a diffraction grating 1,000 lines per millimetre, 1,000 slits per millimetre. If our laser beams are millimetre wide, that means that at every maxima there are 1,000 sources interfering constructively. That's going to be bright if our laser beam is 1 millimetre wide. Versus double slit, how many sources?
2.
2. The clue's in the name. Okay, what was, so Money's other thing was concentrated. What do you mean by concentrated?
It's like a more compact light source. Light source, more like where the maxima is formed,
Yeah.
The light source is less spread and it's more compact into like a dot.
Okay.
It's like smaller and less maximum. But
So what does that mean about the space in between the maxima on both different patterns?
Larger.
So is it
lighter minima, darker minima, or bigger minima.
So on a double source, do we ever really get no light?
Barely. It's just like it's
Kind of gets
tiny.
dimmer and dimmer and dimmer, and then brighter and brighter and brighter, dimmer, 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 brighter, brighter, brighter. Whereas the diffraction grating is super bright
Nothing.
and then nothing.
For
And so that
you know having perfect interface destructive interaction
But is it
be completely flat?
should be, yeah.
That's not
And so with the double slit, as we move slightly off the maxima, we see that the two sources move slightly out of phase with each other. Not exactly out of phase, but slightly out of phase. And so our light goes from being brightest to just a little bit bright. And then as they move further and further out of phase, it gets dimmer and dimmer. And there is an instant when they're 180 degrees out of phase, like in between the two maxima, where there should be almost no light. It should be no light. But that's a very narrow band, in the same way that the bright piece, it's hard to distinguish exactly where the centre of the maxima is. It's hard to distinguish exactly where the minima is, because on each side of that point, there's going to be a little bit of light. Smudged maxima, and that's because so when we're not exactly on a maxima, the two sources are still somewhat in phase, and so there's still some light sense. We never really get that darkness. Whereas on the diffraction grating, we get really distinct maxima and absolutely nothing in between. Okay, so the explanation is a little bit more complicated for this, and that's that there are many, many sources in a diffraction grating. And so when you move off at a maxima, every single one of those many sources is in phase, and that's why those maxima are so bright. But as soon as you move just a tiny bit off that, every single one of those sources is going to have another one of the sources that it interferes destructively with. And so not every source is going to interfere destructively with every other source, but as soon as you move off, then one, like the first source might interfere destructively with the 293rd source, and the second source might interfere destructively with another one. They all interfere destructively with one of the other sources, and so you do end up with that no light being seen, with that darkness in between the really distinct, concentrated bright patches. Does that sort of make sense? Action?
Yeah.
Okay. So there's two kind of different things that are happening in our double slit. This is continuing along the theme of the double slit pattern versus the diffraction grating pattern. This is our double slit here. This is diffraction grating. And so one of those things is that on the double slit, our pattern is it's like seen only in a very narrow wedge of angle, whereas the diffraction grating, our pattern was spread across like a really wide angle. The other thing is that, and that was because of the diffraction grating having slits that are really, really close, they're really, really narrow slits, so we get really, really good diffraction happening. The other thing is that the maxima are really, really close together as well on a double slit pattern. Like we had to shine the pattern right from the back of the classroom to the front to be able to see between them, whereas on the diffraction grating there's a huge distance between them. Why is that happening? What's going on there? It's not the angles. Like, what can you change in that equation that's going to change the angle? The D, right? What can you tell me about the distance between the slits as opposed to the size of the slits themselves?
It's decreased, isn't it?
on a diffraction grating they are.
Oh, increase. Oh, no.
Wait,
Hey, try a double slit with a diffraction grating.
D would be greater
D is greater where?
on the double slit.
On the double slit. So maxima are close together because the slit spacing, the distance from one slit to the next one, is big. Whereas on the diffraction grating, what happens if we have to cram in like 200, 300, 600, 1,000 lines per millimetre? What must happen to the spacing between them? It's got to decrease. So the reason that the maxima are widespread is because to make this diffraction grating we had to push those slits closer and closer together. We could make a really flash set of double slits with two slits really, really close to each other, and they would spread the maxima as much as a diffraction grating would, but it would also smudge it. It would just smudge that light out really, really white. Does that make sense to anyone?
I wasn't listening.
Yes.
So there's two, it's complicated because there's two things that are happening. The first one is that our whole pattern from the diffraction grating is spread out really, really wide, and that's because the slits on the diffraction grating, the slits are narrow, and that means as the light goes through, its wavelength is similar to the slit size, and so it diffracts really, really wide.
Yeah, that makes a lot of sense actually.
The other thing is that the slits on a diffraction grating, as well as being really narrow, they're really close together. And as we make D smaller, N's the same, lambda's the same, the angle must get bigger to compensate for it. And so the maximum move further apart. So two different things, how wide the angle is, the pattern is seen across like the whole pattern, and then the angle from one maxima to the next maxima.